This video talks about the basics of branching. I'm Karen Agar from the University of Georgia, and this video is a part of SAIL-CS, System for Adaptive Interest-Based Learning for Computer Science. Let's say that you wanted to design an algorithm that displayed either pass or fail given an int variable grade. Your program would need to read in that input from the user, an int between 0 and 100, and then tell them if they passed or failed. Passing is 70 or above. Using plain English, what would the steps be to solve this problem? Well, first we would want to read in the user's grade and store it in an int variable. But then what? You would want to do something along the lines of checking to see if the grade was greater than or equal to 70. If so, then we want to say pass. Otherwise, we would want to display failed. So if the grade was anything below 70, display fail. How would we do this? So up until this point, we haven't really talked much about flow of control. Flow of control is the order in which a program performs its actions. So everything that you've written so far has been executed in sequential order, meaning left to right, top to bottom. A branching statement is a statement that chooses between two or more possible actions. In this case, the flow of control is going to branch in two or more possible directions. We're either going to print pass or fail, but not both. The most basic form of a branching statement is called the if-else statement. This is a branching statement that chooses between two possible actions. We can see the syntax below here. We use the keyword if, followed by a Boolean expression enclosed in parentheses. This Boolean expression is something that evaluates to either true or false. So for example, if count is greater than 3, this is something that would evaluate to either true or false. If count was 0, then 0 greater than 3 would evaluate to false. If it was 4, then 4 greater than 3 would evaluate to true. We could also do something like if A was less than or equal to B. This statement here, statement A, is going to execute anytime this Boolean expression evaluates to true. What we want to execute if this Boolean expression evaluates to false would be statement B. So the flow of control looks like this. We start, we evaluate the Boolean expression, what's in these parentheses. If that evaluates to true, we execute whatever is under the if statement here. If it evaluates to false, we execute whatever is under the else statement here. Let's look at an example. So here I've created a basic Java class called Basic Branching. Notice I've imported the scanner package, created a scanner object, and then read in an int from the user and stored it in a variable called grade. So what I'm going to do here is I'm going to create our first branching statement. So I'm going to say if, and notice that it populated the parentheses for me. We want to put our Boolean expression inside these parentheses. So what we're checking for here is if the grade is passing. We said passing was 70 or above, so I'm going to say if grade is greater than or equal to 70. So if this evaluates true, grade is something greater than or equal to 70, then I'm going to print out system.out.println pass. Else, so if this evaluates to false, I'm going to print out system.out.println fail. Now notice a few syntax things here. Notice that I do not have a semicolon after if and the Boolean expression, nor do I have a semicolon after else. Whenever you have a print line statement or any normal statement that you want to execute, you use semicolons like you're used to. But putting a semicolon after the if or after the else will break your program. Let's go ahead and run this. So it's waiting for some user input. If I were to put in the grade of 65, then 65 would be greater than or equal to 70? No, that's false. So it should print fail. And it does. If I run this again and put a value greater than 70, so let's put 80 in this time, then this evaluates to true and we print pass. If I wanted to execute more than one statement if grade was greater than or equal to 70, like let's say instead of just printing out pass, I also want to print out great job, then what I would need to do is enclose both of these statements in braces, like this. Note that anything enclosed in braces like this is called a block, and these are called compound statements, meaning that there's more than one statement. I could also do this with the else. So else, let's enclose this in braces. system.out.println fail, and then system.out.println try again. Notice that indentation, like usual, doesn't matter, but just to make it look nicer, I'm going to align it. And let's run this. Again, if I put in 99, it's going to say pass and great job. So if I were to take these braces out, what do you think is going to happen? So let's say I run this. I put in a grade of 50, right? This whole block will be skipped over because 50 is not greater than or equal to 70. So it's going to go in the else, right? It's going to print fail. And then do you think it's going to print try again? Absolutely, right? Because again, our flow of control is top to bottom. It's going to print try again. Let's show how this happens. So I put in the grade of 50, fail, try again. Now the real question is, did it print try again because it was the next statement in the order of flow of control, or did it print try again because grade greater than or equal to 70 failed? So if I were to run this again and put in a grade of 99, we're going to go inside this block, right? 99 is greater than or equal to 70, so we're going to print out pass and we're going to print out great job. We know that it skips over whatever is inside the else block, right? So it should not print out fail, but will it print out try again? Let's run it and see. So 99, pass, great job, and try again. So what happened here is that since we left off the braces, which is a common mistake, it only thinks that this first statement is associated with the else. Even though I have this indented here to make it look like it's associated with the else, it's actually just the next statement in order. So any other statements that you would normally write in your program would follow your normal flow of control, executing in sequential linear order. So again, in order to fix this and have this work the right way, I would need to enclose this in braces, making this a compound statement. Let's talk about what would happen if we left off the else. Here we have an example where we said if grade is less than 0, then we're going to print out error. Below that, we have system.out.println grade. There's no else statement here, so nothing's going to happen if the grade is greater than 0. So if this condition evaluates to false. Either way, system.out.println grade is the next item in flow of control. It does not depend on this Boolean expression. So the way that the flow of control works here is we evaluate the Boolean expression. If it's true, then we get to execute whatever statements are associated with this if statement here. If it's false, it doesn't matter. We skipped over anything else to do if it's false, and we're just going to continue program execution as normal. So now I'd like to talk a little bit more about these Boolean expressions that we're putting in the parentheses. We looked at some pretty basic examples, but there's some more rules that we should get familiar with. So again, the value has to be something that's either going to evaluate to true or false. And we saw some examples like count greater than 3 or A less than or equal to B. What if we wanted to check if a grade was equal to 0? We need to become familiar with some of these Java comparison operators. The way to accomplish this is through a double equal sign. We usually pronounce this as equals equals. And what this does is it checks if two different operators are equal to each other. So we could say something like if A equals B. Then we have the not equal to. So you can see here that you use an exclamation point and an equal sign. And that checks if A is not equal to B. And then we've got the normal less than, greater than, less than or equal to, or greater than equal to that we've been using. So again, here's some examples. If grade equals 0, checks if grade is in fact 0. Or if choice, let's say choice was a char character. If choice was not equal to D, we could do things like this. So let's talk about the single equal sign versus the double equal sign. Why can't we just use a single equal sign as a comparison operator? Well, remember, this single equal sign, we call that the assignment operator. And what that means is that normally when we program, we say something like x equal 5. What happens is we take the value 5 and we store it in the variable x. So this is actually just going to be like an int, right? We're taking 5, storing it in x. If we were to put a statement like that inside an if statement, if x equal 5, then what it's doing is it's taking 5, storing it in x, so then we just have a variable x, which is set equal to 5. This doesn't return true or false, right? So we're going to get an error. That's the reason we need to distinguish between equal, the assignment operator, and equals, the comparison operator. So if x equals 5, this is the correct logic. This is actually going to check if x holds the value 5. The comparison operator is only appropriate for comparing variables of certain types. I can basically only use it with ints, booleans, or chars. So in this example, I've got if a equals 3. If a is an int variable, then this is a legal statement. Note that this also works for any of the primitive integer types, like longs or bytes. I can also say something like if b equals false, where b is a Boolean variable, or if c equals a, where c is a char. So this means that I cannot use the comparison operator, equals, to compare floats, doubles, strings, or any other objects. We'll look at methods to compare these later on. Boolean expressions can be combined to create a compound Boolean expression. In this example, we're going to combine them using the AND operator. Notice that the AND is just two ampersands together. So we have this example, if x equals 4 and y equals 11. This expression is true only when both of the smaller expressions are true, meaning that x equal 4 would have to evaluate to true, and y equals 11 would have to evaluate to true in order for this entire Boolean expression to evaluate to true. Note that these parentheses here are often added for readability, but I could leave out this inner set of parentheses and it would work just fine. Boolean expressions can also be combined using the OR operator. The OR operator are these two vertical bars. In this example, I've got if quantity is greater than 5 or cost is less than 10. This entire expression is true if either of these smaller expressions are true. So if quantity is greater than 5 evaluates to false, but cost less than 10 evaluates to true, then this entire expression is true. Let's see if this is a valid compound Boolean expression. We've got if score is greater than 0 and less than or equal to 100. Is this valid? The answer is no, because if score is greater than 0, score greater than 0 can evaluate to either true or false, but on the other side of this ampersand, we've got less than or equal to 100. This operator, less than or equal to, needs two operands. We're missing one here. So in order for it to be fixed, we would need to say if score greater than 0 and score less than or equal to 100. What about this? If 0 is less than score, which is less than or equal to 100. Well, we're not even using the compound operator here, and, right? So this is not going to be valid either. What actually happens here is that the computer tries to figure out if 0 is less than score. That's going to either return true or false. So then you actually have if true or false is less than or equal to 100. That doesn't make sense, so it's going to give you an error. Sometimes only part of a Boolean expression needs to be evaluated to determine if the whole thing is true. So if I have an OR statement, A or B, we know that either one of these could be true for the entire expression to be true. So the computer's sometimes lazy. It starts evaluating left to right. If it sees that what's on the left side of this OR, if A is true, then it knows that the whole thing is going to be true. It doesn't really matter what the value of B is. So it skips it. It's lazy. We have this AND operator, and we know that both have to be true in order for the entire thing to be true. So if the computer sees that A is false, then it doesn't matter what B is. The entire thing is going to be false, so it skips it. So in both of these cases, the program won't evaluate B or whatever's on the right-hand side of these compound operators. This is called short circuit or lazy evaluation. Note that you can negate an entire Boolean expression. So in this example, I've got a Boolean expression and then a not in front of it. Note the exclamation point is called the not operator. So here I've got A or B and not A and B. This would evaluate A or B, assuming that this is true, right? Since short circuit evaluation would skip all of this if this was false, then we would go to evaluate A and B. If this evaluates true, then we negate it, and this entire thing is false on the right-hand side of the and. If A and B is false, then we negate it, and this becomes true. That's it for the basics of branching. So just to overview what we've learned, we learned about flow of control, the order in which things are executed in a program. We then learned that the flow of control can branch in two or more possible directions. We learned about basic branching statements, so our if-else statement. We looked at the syntax, and we looked at an example of how that could work. We then saw that if-else statements can have compound statements, which need to be enclosed in braces, or you can leave off the else, and we saw how program execution continued as normal. We then talked about Boolean expressions, what actually goes inside the parentheses of the if-else statement. We talked about how those need to evaluate to true or false, and then we looked at the different Java comparison operators. So we saw the comparison operator equals equals, talked about how that differed from the assignment operator, the single equal sign, looked at not equals, greater than, less than or equal to, greater than or equal to, and practiced with some of those. We then looked at compound Boolean expressions, how you can combine them using either the and or the or operators. We talked about short circuit evaluation and the way that the computer is sometimes lazy and it only evaluates one side of these compound expressions if it can already figure out what the entire expression is going to be. And then last, we talked about negating Boolean expressions, using that not operator, the single exclamation point, to negate an entire expression. I hope you enjoyed this video and can now go practice the basics of branching.